Hey everybody, this is Mr. Lowry. I'm going to walk you through a couple of the problems from your homework assignment tonight. The homework assignment tonight comes from your textbook. So it starts on page 72 and it goes to 73, and it starts on problem 30. So I'm going to have you do these two, 30 and 31. Okay, and then on the next page you got 32, and then 37, 38, and 39. Okay, so for 30 and 31 and 32, most of the table is already there. You just have to kind of fill it in. The other three problems that you're going to do from this section, you're going to have to make your own table. Okay, so I'll walk you through a couple of those in just a second. What I wanted to point out to you, though, is that whenever you're setting up a truth table, whether it's this guy at number 10 or 30 and 31, what you want to do is you want to list all of the variables that you're using. So if you have two statements, P and Q, then you need a column for P and a column for Q. And typically when you set up those columns, it's almost always the same. Like pretty much it's going to be TT, TF, FT, FF, right? If you go left to right. Or in other words, the P column is going to be TTFF and the Q column is TFTF. Okay, so this is the way you set up any truth table where you have two statements. Okay, it looks going to look just like this, P and Q. So that's definitely something you're going to want to know. Same thing here, right? So in 31, you got a P column, you got a Q column. This is just all the different combinations of truth values for statement P and statement Q. They could either both be true, 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 or the first one could be true and the second one could be false, true, false. Or the first one could be false and the second one's true, false, true, or they could both be false, false, false. Okay, so keeping that in mind, I'm going to walk you through number 37 and 39. Okay, and then you can try 38 on your own. So this is a little bit zoomed out here just so you can see everything. I'm going to zoom in now. Okay, so 37 is construct a truth table for each compound statement. So this says Q and not R. Okay. Well, what that tells me is I'm using the variables Q and R. So the very first thing I'm going to do for my truth table is I'm going to make a column for Q and I'm going to make a column for R. Okay? When I'm making a truth table, this, whatever's right here, the thing that I'm actually trying to make a truth table for, that's going to be my last column, and every other column are just going to be building blocks. So I already have Q, right? And I already have R. I need a column for not R because that's one of the building blocks here. So the next column is going to be, I'm going to do a not R column. Okay, and then my final column for this one will be actually the truth table I'm trying to construct, which is Q and not R. Okay, so for each of those guys, I'm going to have a column. Every column but the last column is what we call like a helper column. Right? It's just to help us get the last thing. When you do an and or an or a conditional statement, you're doing it with two variables and their letters. And so we gotta basically, we can only look at two columns at a time essentially. Okay, so how we're gonna set this one up, let me do this as well, is the same way we set up any other truth table where we have two variables. We're gonna list all the different combinations of truth values for those two statements. And we list them this way. This is just a convention. We want to make sure we get them all, but this is typically how they're listed. And if you want to make sure that when you check your answers in the back of the book, your truth table is going to be set up in this order, so it's kind of important to do it that way. So start by assuming that both statements are true, and then you could say, okay, maybe assume that only the first statement is true and the second one's not, or that the first statement's not true but the second statement is true, or they're both false. Okay, so that's basically how you set up pretty much any truth table. All right, now the next one is the helper column R, because notice in my final statement here, I'm going to combine Q and not R together with the and operator. So this is and. Okay. And so I need to have the Q column, which I have, and I need to have a not R column as well. I'm going to try to focus really quick. See if that's any better. Okay, sorry. So the not R column is the exact opposite of the R column. So this is a T, this is an F, this is an F, this is a T, this is a T, this is an F, this is an F, this is a T. Okay. Now for the last column, the final column here, I'm going to put Q together with not are, so these are the two columns I'm looking at, and I'm going to combine them with the and operator. Okay? An and statement is only true when both the original statements are both true. Okay? So do I have two true statements? Now we're looking at the first and third column here. So do we have two true statements? No, we don't. So that's false. Do we have two true statements? Yes, we do. So that one's true. Do we have two true statements? No. Do we have two true statements? No. Okay. So going back to our assignment from today, the and operator is how you combine two statements, and the conjunction, which is the statement with the and in it, is only true when both the hypothesis and the conclusion are true. Everything else is false. Okay, so that is number 37. Okay, let's go ahead and do number 38 anyway. I'll just go 37, 38, and 39 for you, just in case. Now what I would do here is, if you are still having a hard time, try 38 on your own first and see how far you can get, and then go back and use the video. Don't just use the video to like copy, because that's not really going to help you learn very much. You got to try first and then see how you did. Okay, and then when you look at the video, I can help you correct any mistakes that you might have made. Okay, so when you look at 38, this is the statement we're trying to do. It's not P and not Q. Okay, so I know I'm using P's and Q's here. So my two variables that I'm using are P and Q. Okay, I know I need a not P column. I know I need a not Q column. And then the final column is going to be not P and not Q. So everything else building up to the last column is just the building blocks of the pieces that I need to do this final statement, right? P and Q is where I start, because those are the letters we're using. I need a not P and I need a not Q, because those are two of the statements in my final statement. And then the last statement is just doing a conjunction or an and statement with not P and not Q. Okay, the first two columns are basically always the same. TT, TF, FT, FF, just by convention. That's just how we set it up every time. All the different possible combinations of the statement P and the statement Q and their truth values. So not P is the exact opposite of P. So false, false, true, true. Okay, not Q is the exact opposite of Q. So false, true, false, true. Okay, now we're using the and operator again. Okay, when we use an and operator, we're creating what we call a conjunction. And the conjunction is only true if the hypothesis and the conclusion are both true. So we are comparing this column and this column, and what we're looking for is two trues. Okay, do we have two trues? Nope. Do we have two trues? Nope. Do we have two trues? Nope. Do we have two trues? Yes, we do. Okay, so that's the truth table for this statement. Okay, these other guys are helpers that are building us up to there. Okay, so that's again using the and operator. This symbol means and it gives you what's called a conjunction, which is only true when both the hypothesis and the conclusion are true. All right, let's take a look at 39. Okay, now in this one, 39, we have three letters, P, Q, and R. And you might be wondering, like, well, how do I set that up? Well, if you've been doing this assignment in order, 32 you've already done, and they show you how to set up all the different possible combinations for P and Q and R, or P, Q, and R as letters. So you can have all three statements be true, or two of them are true and one's false, and there's a couple different ways to do that. Or you could have two of them are false, and one of them's true, and there's a couple different ways to do that, or they could all be false. Okay, so what I would do for 39 is just start by copying this beginning, because this is how you would start any truth table for three variables, basically. Okay, so we're going to do that. We got P, we got Q, we got R. Those are the three letters we're using. We're also going to have a not P at some point and a not R at some point, and then we're also going to have this little statement here, the Q and not R, and then we'll basically put together the first thing and the last thing. So when we use an operator like and or, we can only do it with two statements at a time. So we have to build those statements up as we go. So we got a P, we got a Q, we got a R. We're also going to need a not P, and we're going to need a not R. We're also going to need anything in like parentheses. So this is a full statement. We're going to need Q and not R. So we're going to do that over here. Q and not R. And then the final guy that we want is like the whole thing. So not P or Q and not R. Sorry. All right, so I got a column for these guys, and we need 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got a column for Q, we got a column for R, we got a column for not P, we got a column for not R, we got a column for Q and not R, and then we got our final column, which is what we're kind of looking for at the very end. Okay, so again, we're going to use 32, the template for 32, to kind of help set this up, but you can also just think of it as, you know, just going through all your different combinations here. So they could, all the statements that we're talking about could be true. P, Q, and R could all 3 be true. Or you could have the first 2 true and the last one false. Or the middle one could be false. Or you could have the second 2 both be false. So basically, like, think of it this way. Here's a Q and an R, right? Like this, like a Q and an R. T, 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 F, F, T, F, F. T, 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 F, F, T, F, F. Right? Those are all the different possibilities for Q and R when P is true. Okay, now we're basically going to repeat that, but we're going to make P false. Okay, so we're going to basically say the same thing. TT, TF, FT, FF. We're just going to do that down here for P being false. So TT, TF, FT, FF. Okay. Now, if you don't do it in that order, then your answer is not going to match the answer key, because this is how they're going to set it up. This is not a matter of like right and wrong. It's a matter of convention, like just how we do things, so that we can compare answers and share information. And this is the way we do it when we have 3 variables. Okay, so the not P column is the exact opposite of the P column. So this is T, 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 F, 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 F. So this will be F, 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 T, 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 T. Okay, then we have the not R column, which is the exact opposite of the R column. So F, T, F, T, F, T, F, T. That's the exact opposite of these truth values. Okay, then we have Q and not R. So we're comparing this one, Q, and not R. So those are the 2 we're looking at. And we're combining them with the and symbol. So remember, the and symbol, when we have what we call a conjunction, we use that one. The conjunction is true when both the hypothesis and the conclusion are both true. So again, we're looking for 2 T's in these 2 columns. Do we have 2 T's? We do not. Do we have 2 T's? Yes, we do. Do we have 2 T's? Nope. Do we have 2 T's? Nope. Do we have 2 T's? Nope. Do we have 2 T's? Yes, we do. Do we have 2 T's? Nope. Do we have 2 T's? No. All right, so that's our Q and not R. Again, we're using the and operator, and the truth value of this statement is only true when both the 2 helper statements are both true. So here and here. Okay, so now we're taking not P and then this whole thing, and we're combining them with an or. So this is called a disjunction. Okay, so I'm comparing not P, which is this column, and I'm going to or it, or do a disjunction, with this statement, which I have right here. That's this column. So now these are the 2 columns I'm looking at. Okay, and the or operator, we get a true when at least one of the other 2 columns are true. So if this statement is true or this statement is true, I get a true truth value here. Okay, so these are the 2 we're looking at, not P. and Q and not R, and we're putting them together with this symbol, which again is the disjunction. So we're looking for at least one true to get a true. Do we have at least one true? No, we do not. Do we have at least one true? Yes. At least one true? No. At least one true? No. At least one true? Yes. 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 So all of that was really to get this last column. Sorry, these are F's here. To get this last column, but we need all those helper things. We have to like, kind of break this apart, right? This is a very long and complicated statement. So we just want to deal with two things at a time. So I'm dealing with not P and this junk, right? Okay, well here's the not P column, and here's that column. Remember, this column we built from Q and not R, from this one and this one. So when you look at the final statement, you got to kind of break it down into pieces and build your way up to it. Okay, so that's how you do a truth table there for, that's 39. Okay, so that's 37, 38, and 39. If you weren't sure how to do 30, 31, and 32, that should kind of help you. This, remember, is an OR. This is a disjunction. So you're going to get a T here as long as you have at least one T in the P or Q column. So at least one T, true. 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 At least one T, false. At least one T, false. That's how you get that column. Now this one is going to be an AND, a conjunction, with the column that you just made, and R. Okay, so use the AND operator to combine those two. Remember, you get it for AND, you get a T only if both of these are T. Okay, so that's kind of how you do that one. Over here, sorry, this camera is making it hard to see everything. Over here in 30, this is an disjunction or an OR. Okay, so just do the not P, and then you can combine the not P and the Q. Okay, and then over here you got a conjunction or an AND. Okay, so hopefully those should be pretty easy. 37, 38, and 39 are a little bit harder because they don't set up the table for you. Okay, let's take a look at a few more here. All right, so in this one, in this problem set that I had you do, we're basically looking at a conditional operator because this is a conditional statement. All right, so the relevant piece of information here for this set of problems is actually found on the bottom of page 76. So this is going to be really helpful for you, right down here. Notice that a conditional statement is true in all cases except where the hypothesis is true and the conclusion is false. So when I look at my truth table, the only time I get a false is if the hypothesis is true but the conclusion is false. Everything else is a T. So apply that information here to the problems. Sorry, keep on going. Sorry, I went too far. To the problems here, okay? So if you are over 18 years old, that's the hypothesis, then you vote in all our elections. So basically what you want to do is you want to see, is this true, and then determine if your full conditional is true. Okay, now remember, based on what I just said, you only get a false if the hypothesis is true and the conclusion is false. Okay? So you are 19 years old. That means this is true. You vote. That means this is true. Right? So what do you get? If P is true and Q is true in your conditional statement, what do you get? Okay? All right, here we got a false and a true. Here we got a true and a false. And then here we got a false and a false. So essentially you're looking at like a kind of like a truth table basically. You're basically looking at a truth table kind of like this, but for a specific situation. So that should help you out there. Okay, let's look at the next problem set. So here we got, write the converse, inverse, and contrapositive of each conditional statement. Determine whether each related conditional is true or false. If the statement is false, find a counterexample. Okay, so you got a couple from this section. You got 41 and 42. Okay, now 41, I actually kind of regret giving you this one because I think that determining whether this is true or false is a little bit hard to do. So we'll kind of go through it together and think about what we think about that one. Okay, so this will be 41. First thing we want to do is we want to determine what's the hypothesis and what's the conclusion. Okay, so the hypothesis comes after the if. So you exercise regularly is the P, the hypothesis. You are in good shape is the Q, is the conclusion. Okay. So once we have that, we can use this table on page 77 to help us write the converse, inverse, and contrapositive. And these symbols kind of tell us like what to do, and this is kind of the wording. So if I have an original statement and I want the converse, I just flip the if part and the then part, or I exchange the hypothesis and the conclusion. Okay? For inverse, I negate both the hypothesis and conclusion. And then for the contrapositive, I negate both the hypothesis and conclusion of the converse. Meaning I do both. I take the original and I flip it to get the converse, and then I negate the converse to get the contrapositive. All right, let's do that together. So I'm going to write some stuff out here for 40. So this is the original. If you exercise regularly, then, let's see, it says then you are in good shape. All right, and I'm going to kind of mark this up a little bit or annotate this. So this is the P, or the hypothesis of the original. This is the Q, or the conclusion. And for the converse, what I want to do is I want to change the order of the hypothesis and the conclusion. Okay, so I'm going to start with Q and I'm going to go to P. So that would be if you are in good shape, then you exercise regularly. Okay. Now we're supposed to get like a truth value for each of these. We'll come back and do that in just a second. Let's go ahead and do our inverse now. So to find the inverse, we're just going to negate P and Q from the original. Okay, so not P implies not Q, or if not P, then not Q, or if I don't exercise regularly, then I am not in good shape. Okay. Then we have the contrapositive, which essentially is doing both the inverse and the converse at the same time. So it's either the converse of the inverse or the inverse of the converse, however you want to think about it. Basically, we're going to negate both statements, and we're going to switch the order as well. So not P implies not Q, or if not Q, then not P. Or if I am not in good shape, then I do not exercise. So sorry, if you are not in good shape, then you do not exercise regularly. Okay, so that part's actually not too bad, but the hard part, I think, of this problem is determining the truth values, like are they true or false, because it kind of depends on your definition of exercising regularly and in shape. So typically in math, we define things very precisely, right? Like we know what a right angle is, and we know what a linear pair is, and things like that. We haven't really defined what it means to be in good shape. We haven't really defined what it means to exercise regularly. So determining if these statements are true and false is kind of tricky. So this is probably what I would do. If you exercise regularly, then you are in good shape. So basically what you're saying is every person who exercises regularly is in good shape. You could probably argue that one either way. I'm going to say that that's mostly true. Of course, we can, probably find an example. But I would say for the most part, if you exercise regularly, then you are probably in pretty good shape. Okay. Now, one of the things we talked about in the in-class assignment today was logical equivalence. So just because a statement is true doesn't necessarily mean its converse or inverse will also be true. So if we look at this one, if you are in good shape, then you exercise regularly. You could argue that that might be true as well, but think about this for a second. Do you know anybody that's in good shape that doesn't exercise regularly? Because if you do, then you've found yourself a counterexample. So I would probably say that this is false, generally speaking, and it asks you to give a counterexample. And so I would just come up with somebody that you might know that is in good shape that doesn't exercise, right? Like you could say something like, oh, my brother is in great shape, and he never exercises. He always is just playing video games, or something like that, right? You don't have to do a specific example. You could just say, there are people out there that are in good shape that don't exercise regularly, and that would be kind of a counterexample. Okay? The inverse and the converse actually always have the same truth value. These guys are always logically equivalent. So if your converse is false, your inverse is also going to be false. Okay? And you could use a similar counterexample. If you don't exercise regularly, then you are not in good shape. Well, again, we could probably find an example of somebody who doesn't exercise as regularly and is in good shape. And so you just want to state that as your counterexample. So you could say, like, my little sister, who is 14, doesn't exercise as regularly, and yet she is in good shape. Right? Again, we haven't really defined what in good shape means, and this is probably a bad one to pick on my part. So I'm just going to say false there, and you could use that kind of counterexample. Okay, now the contrapositive and the original statement always have the same truth value. Okay, so if the original statement is true, and we said it was, then the contrapositive will also be true. Okay, those always go together. So we call these logically equivalent. The original conditional statement and the contrapositive are always logically equivalent. The converse and the inverse are always logically equivalent to each other, meaning they always have the same truth value. However, just because the original statement is true doesn't mean the converse is true, or doesn't mean the inverse is true as well. Okay, so that's probably how I would do that. Now, again, you could argue it probably either way. This is a little bit open-ended. So if you got something different than that, in terms of your truth values, that's probably fine. But mainly, want to make sure you can get the converse, inverse, and contrapositive. Okay. All right, let's take a look at 42. Okay, the trick on 42 is that it's not already in if-then form. And so in order to kind of find out what the hypothesis and conclusion are, we have to force it to be in if-then form, but that's pretty easy to do. So the sum of two complementary angles is 90 degrees. So we would just change that. If two angles are complementary, then their sum is 90 degrees. Right, so something like that. So 42, I'm going to say, if two angles are complementary, then their sum is 90 degrees. Okay, so that's the original. Now we want to make the converse. So two angles being complementary, that's the hypothesis. The sum being 90 degrees is the conclusion. And for the converse, we want to reverse the hypothesis and the conclusion. So instead of P implies Q, we want Q implies P. So if two angles sum to 90 degrees, then they are complementary. Okay, that's the converse. For the inverse, we're going to take the original statement and we're just going to negate the P and the Q. So this is not P implies not Q. So I would say if two angles are not complementary, then their sum is not 90. Okay, so, and then the contrapositive is going to do both. It's going to change the order of the original P and Q and negate the original P and Q. So the contrapositive is not Q implies not P. So that's, sorry, that's an arrow there. So we want to say if two angles do not sum to 90, then they are not complementary. Okay. Now, all of those are actually true because the definition of complementary is that they add to 90 degrees. And if you're dealing with a definition, then the definition will work both ways. Theorems and postulates don't always work that way, but for definitions, it does. So if two angles sum to 90, then they are complementary. Yeah, that's true. Any two angles that sum to 90 are going to be called complementary. So that's actually a true statement. If two angles are not complementary, then their sum is not 90. That is absolutely true. If they don't add to 90 degrees, and if they're not complementary, then they do not add to 90 degrees. That is a true statement. Okay, if two angles do not sum to 90, then they certainly are not complementary. So all of those are actually true statements. That one's a little bit easier to determine the truth value, whether it's true or false, because this is based on actual definitions that we have. And so you can see how not having precise definitions, like what does it mean to be in good shape, what does it mean to exercise regularly, not having those definitions makes our work here a little bit harder to do. When we have precise definitions, like we know what the definition of complementary is, then we can come up with true and false a lot easier. Okay. All right, now most of you guys, especially if you were at UCAS, have had that content before. Okay, if you have not had that content before because you were not at UCAS last year, then you're probably going to need to spend some extra time studying. So I would go back and watch all the videos for that I posted in this assignment. I would go back and read both of those sections and make sure that you understand those, because we don't have time scheduled this year to go through those slowly like we normally would in SM1. We're just going to kind of assume you know them. So if you want to do well in geometry, you're gonna, and you didn't have any geometry last year, you're probably going to have to put in a little extra study time. If you need help, let me know. Send me an email. Come in before or after school, and we can help you out. Thanks for watching, guys.